Hi everyone, myself Bidyutlata Sahoo, working as an assistant professor in the Department of CSC, Artificial Intelligence and Machine Learning at Institute of Aeronautical Engineering, Hyderabad. In this video lecture, now I'm going to discuss about the problem solving question discussion on MiniMax algorithm. In my previous video already I have discussed the whole concept of MiniMax algorithm, where it is used and why it is used, how to solve the problem. Few more problems now I'm going to discuss today. This is the course outcome for this course. After the completion of this course, students can apply the bounded look-ahead strategies to predict future states for decision making in gaming applications. Now let me discuss what is MiniMax algorithm. This MiniMax algorithm especially it is used for game playing process. Why not other algorithms? Why MiniMax algorithm? Because the game problems are too complex, where more number of steps are required to solve the problem, and as well as the state space is more and the number of repetitions are required to explore each node. That is why the adversarial search techniques are used instead of informed or uninformed search techniques. So MiniMax comes under the adversarial search technique, where it is first of all it is a two-player game. One is the max player, another one is the min player. Two player will play opponent to each other, and max player always try to achieve the max value, and min player always try to achieve the minimum value, and min player always try to gain the advantage of the max player. Now these are the steps of the minimax player. The step 1 says that generate the game tree first, the state space. Then step 2 says apply the utility function to each terminal state to get its value. Utility function is nothing but the heuristic value, and that heuristic value should be given to the leaf node or the terminal node only. Then using that utility value in step 3, use these values to determine the utility of the nodes one level higher up in the search tree. Means we have to explore the tree from the bottom to top, not from top to bottom like other algorithms. Now while exploring from bottom to top, for a max level, select the maximum value of its successor, and for a mean level, select the minimum value of its successor. And step 4 says, from the root node, select the move which leads to the highest value. Now this algorithm you can easily understand once I will solve this question. This is question number 1 related to MiniMax algorithm. So here, as per the algorithm as I discussed, it is a two-player game where one player is maximizer, another player is minimizer. So, and all the utility values for each terminal node are already given. So, what are the terminal nodes in this search space? H, I, J, K, L, M, N, O. These are the terminal nodes and their heuristic values are given. Heuristic value means the value from the current node to the goal node. That is called as the heuristic value. Okay. So, both the players, as it is applicable for two-player game, both the players, both maximizer and minimizer, they will play opponent to each other, means one after the other, to achieve the advantage or to win the game. Okay, and we have to explore this search tree from bottom to top, not from top to bottom, right? So as the terminal nodes values are given, that value, utility values will be propagated to the next level. Then once we will find D, E, F, G utilities value, that will be propagated to the next higher level. Once we will find the utility value of B and C, that will be propagated to the top. This is the way we can find out the heuristic value or the utility values for all the nodes if the utility values of all the terminal nodes are given. Now let us solve this problem. So now to solve this problem, as it is a two-player game, we are considering two threshold values. For max player, we are taking the threshold values as alpha, whose worst case value we can consider as -infinity, and the mean player, we can take the threshold value as beta, we can represent, and whose threshold value is considered as +infinity. So for whenever we will explore the max play for we will explore the max player layer, then we have to compare with minus infinity, and whenever we'll explore the min player layer, then we have to compare with the plus infinity. Okay, now let us explore the or let us find out the value of D, E, F, G. Because all the terminal node values are given, we have to find out the value of D, E, F, and G. All D, E, F, G, all these four nodes are present in the which layer? Are present in the max layer. Because both the players, they are playing alternatively. First layer is maximizer, next one is minimizer, then maximizer, and the last one is the terminal nodes. All the values for the terminal nodes are given. Now you find out for the node D. How to find? For node D, first, the worst case, as it is a max player, because in the max layer it is present, so we will compare we will compare with minus infinity value. So max of minus infinity, and what is the left child of D? Left child of D is H, whose value is -1. So which one is maximum? Definitely -1 is maximum. Now again we'll compare max of -1, and the right child of D is I, whose value is 4. So what is the max between -1 and 4? It is 4. Now the value of D, we got that it is 4. Similarly, we can find the node value for E by comparing. So for node E, we can write max of minus infinity. We'll compare with J node first, whose value is 2. So maximum is equal to 2 here. Again, we'll find out max between J and K, means 2 and 6. What is the value? 6. So this is the value. Similar way, we can find the max of F by comparing in minus infinity and -3, which is max -3. Then -3 and -5, which is max, again -3. So this is the value for F. Same thing for G. Or how to find out max of minus infinity and compare the left child, whose heuristic value is 0. So minus infinity and 0, which one is maximum? 0. Again compare 0 and 7. Which one is maximum? 7 is maximum. So we got that 7 is the max heuristic value. Now we got this layer is explored, means max player, terminal node above layer is explored, whose value, like now we got that the utility value of D is 4, utility value of E is 6, F is -3, and G is 7. Now we have to move one step up. Same way, same formula we have to apply to. Now you check while calculating the value, heuristic value or utility value of B and C, we have to check in which layer they are present, who is playing. So who is playing here? Minimizer is playing. That means what we have to do? So here we will not take minus infinity. Here we will take the worst case value of the minimizer, that is plus infinity. So for node B, we can write, we will find the minimum value between plus infinity and what is the child? Two children are there. One is D and E. So what is the value of D here? 4. So what is the minimum value between infinity and 4? It is 4. Okay, so again we'll compare minimum between 4 and another child is E, whose value is 6. So minimum is 4. So we can write here the value is 4. Same way we can find for the C node. So C, it is present in the minimizer layer. So compare infinity and -3. So -3 is minimum and -3 and 7. So which one is the minimum? -3 is minimum. So we can write as here, we can write as -3. Now we got both the utilities value for B and C. I hope we can get the value of A. A is the max player. So we'll compare minus infinity to 4. Minus infinity and 4, who is max? 4 is max. 4 and -3, who is max? Again 4 is max. So we got the value of A as 4. Now you can find out the optimal path. Who has owned the game? The maximizer has owned the game and the maximum value is 4. How we got? Here we got this because A is a max player and this value we got from this value and this 4 we got from this side and this 4 we got from. So this is the particular path using which we got the value, we reached the destination. So this is the way we can solve the MiniMax algorithm. So who is the winner here? Winner is the max player, and whose max value is 4. Now let us come to another problem. Same MiniMax algorithm will solve. I hope you might have understood now. It easily. I will not write. Easily you can understand. Here the tree is A is the root node, B, C are the children of A, and D, E, F, G in another level, and all the utilities values are given for the child node. So two player, one is max player, min player. Both the players, they are playing opponent to each other alternatively. If max starts first, then min, then max, then min, like this they will play. Now same thing for now we have to find out the node value for D, as D, E, F, G. All the 4 nodes are the max player. So we have to compare with minus infinity, and we have to find out the maximum. So for D, minus infinity, because the threshold value for max player is minus infinity. So minus infinity gets compared with the left child node of D. Minus infinity and 3, max is 3. Again 3 and 5 gets compared, max is 5. So the node value of D would be 5, means the heuristic value of D would be 5. Same thing for E. Minus infinity gets compared with 6, left child node. So 6 is max. Then 6 and 9 gets compared, 9 is max. So the value of 9, value of utility value of E would be 9. Same thing for F. The minus infinity gets compared with the left child node 1. So here 1 is maximum. Then 1 and 2 gets compared. So 2 is max. So utility value of F has been changed to, we got that 2. Same thing for G node. Minus infinity gets compared with 0 first. So 0 is the max value. Again 0 and minus 1 gets compared. So we are getting 0. So 0 is the max value. Now we got the utility value for D, then E, then F and G. This layer is finished. Now we have to move one step up. So one step up means we have two child, one is B and C. So for the B node, how to find out? Both B and C are in min layer. So we will compare the threshold value of the min player, that is infinity, and we will calculate what is the mean value. So infinity gets compared with the utility value of D, infinity and 5, minimum is 5. Again 5 and 9 gets compared, minimum is 5. So answer for the utility value for B would be 5. Same thing for the seed node. Infinity gets compared with the left child node, that is F. So infinity and 2. So what is the minimum value? 2. Then 2 compare with 0. Okay, the utility value of 0. The utility value of G is 0. So 2 and 0, minimum value is 0. So here the utility value of C would be 0. Now we got these two also. Now again the process will move one step up. What is the how to find out? A is a max player. So minus infinity gets compared with 5 first. So 5 is maximum. And then 5 and 0 gets compared. Again 5 is maximum. So we got 5 here. Now you can find out who is the winner here, as max player started the game. So max will be the winner. And what is the maximum value here? This 5 we got from this path. Then this 5 we got from this path, and this 5 we got from this path. So the maximum value is 5 here, and this is the optimal path for this MiniMax problem. I hope you might have understood this MiniMax algorithm and both the problems. For the preparation of this video, I referred this textbook, Horoscope for Artificial Intelligence. You can also refer it. For your reference, I kept the picture of this book, which is available in Amazon website. Next class, I will discuss some problem related to alphabet pruning. So thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.